Good day all. I was asked to work through this page on in your chemistry book, page 137, question. I'm not sure whether it was question 3 and 4, so I'll just do both the questions. So question 3 says a sample of gas has a volume of 750 cubic centimeters, so that is the volume, at standard temperature. So standard temperature is 298. Let's see what the book says. Standard temperature is 273 Kelvin, or 0 degrees Celsius, but we need to work in Kelvin because we can't work in degrees Celsius because there are gases at 0 degrees Celsius and you can't divide by 0, and if you've worked through these things you would have seen that you often have to divide by the temperature. Calculate the volume at 200 degrees Celsius. So the temperature of 200 degrees Celsius is not in the right unit. So what do I have to do? I have to change it to a Kelvin. So 200 degrees Celsius plus 273 gives you the Kelvin degrees of 473 Kelvin. I assume that the pressure will be constant. It looks like Charles's law being discussed here. Charles's law. So we work with, on your data sheet you will see the following equation. P1 V1 over T1 equals P2 V2 over T2, but the pressure is constant, so I'm going to eliminate it from the equation. So P2 and P1 can disappear. So your equation basically is V1, which is 750 over T1, which is 273, equals V2 is the one that we don't know, we need to calculate it, over 473 Kelvin. So with this calculation it doesn't matter that the volume is in cubic centimeters, as long as your answers, as long as the two volumes will be in the same unit, it doesn't matter. Okay, so I hope you can calculate V2 there, and it will be in cubic centimeters. Question 4, the volume of a fixed mass of gas is 400 cubic centimeters. So this is the volume 1, V1, at STP. So the temperature is 273 Kelvin and the pressure is 101.3 kilopascals. So calculate the volumes at the following temperatures if the pressure remains constant. So I'm going to use this equation again here, and because pressure is constant, I will eliminate it from the equation. So the problem here is that T2 is minus 10 degrees Celsius, which you need to change into Kelvin by adding 273. Each time a degree Celsius you add 273, so that was 263 Kelvin. So you're going to use the same equation, V1 over T1 equals V2 over T2. Your V1 is the 400, your T1 is the 273, your V2 is the one you need to calculate, and your T2 is the 263. So I'm sure you'll be able to calculate V2, and once again the answer will be in cubic centimeters. Right. Question 4.2 is the same situation. You're going to have to change the temperature of 30 degrees Celsius to Kelvin by adding 273 Kelvin to it. So that would be 303 Kelvin, and you substitute it into the same equation. I see that question 4.3 and 4.4, they've already given the temperature, the second temperature in Kelvin, so you don't have to do the conversion there. I hope this helped. If it doesn't, please let me know. Thank you very much.